Hello, kiddos. We're going to do two things today. In this video, we are going to find inverses and we're going to graph logarithms, okay? And so you should have notes from this already. And so we're going to go right into finding inverses. So we have y equals, the first one, log base 3 of x. Okay, we should know from way back, let's see here, we did this in chapter 7, I guess, so not way back, but to find an inverse, we first switch x and y. So we have x equals log base 3 of y, okay? But then I'm trying to get y by itself. Well, the only way to get a log by itself, the only way to remove a log so that I can get y by itself is by rewriting in power form or in exponential form. So remember, we use the base 3 to the x equals y. And now I have y by itself. Now, sometimes it's not always that easy. For instance, if we take a look at the second one, we have y equals natural log of x plus 1. So we need to switch x and y first. Well, y is locked in right now. You might think that you could subtract that 1 over, but in this case, that 1 and that y are locked in that parenthesis, and so we need to get rid of this logarithm. Now, this is a natural logarithm, so remember his base is e, even if I can't see it, so we're ready to write this guy as a power. E to the x equals, this time it's going to be this entire thing that was being logarithmed, okay? So we have e to the x equals y plus 1. Now remember, my goal is still to try to get y by itself, so now I can subtract that 1 over. Okay, so that's finding inverses. Switch x and y and solve for y, but remember, most of the time I'm going to have to rewrite it as a power to be able to get to get y by itself. Okay, so now we're ready to graph. Again, you should have notes on this. And so we have, for the first one, y equals log base 1/3 of x minus 1. Now, this is tricky here because this looks like it's log of x minus 1, but remember, since this isn't in parentheses, this is actually just log base 1/3 of x. Okay? All right. Now, if you take a look at your notes, it says the first thing that we need to do is get it written in power form so that we can actually make an XY table that makes sense, okay? And so to be able to write it in power form, we have to get that log by itself. So we're going to add the 1 because remember, he wasn't in parentheses, so he's not a part of the log. Now we're going to write it as a power. So our base is 1/3. It's being raised to everything over here. Okay? Now, this is where it gets a little tricky in our mind because usually when we graph, when we make an XY table, we have y by itself. We put something in for x and we find y, but that's not the case here. That's not the case here. Here, we're going to do a backwards XY table. So we have, here's our x and our y, and we're actually putting numbers in for y, and we're going to solve for x. We're putting numbers in for y, and we solve for x. Now, sometimes people say, well, I don't know what to put in. Well, I kind of base myself off a couple things here. X cannot be negative. It can never, ever, ever. You can't take a negative of a logarithm. So if you put a number in for y and you get a negative number, you know you've done something wrong, okay? Furthermore, any power that's positive here could never be negative, so that could be another trigger for you. Really, other than that, you can put in whatever you want. So I'm going to put in some things that maybe work well with this 1/3. So 0 would be an easy piece. If I put 0 plus 1 would be 1, and 1/3 to the 1 power is 1/3. Maybe I want to get rid of that fraction. Well, that would mean I could put a negative in here. So maybe if I put -2 in, -2 plus 1 would be -1. That would flip this fraction and make it 3. Maybe I want to go one step further and go, what if I put -3 in? -3 plus 1 would be -2. That would flip it and square it, which would be 9. Okay, so I've got some points there to graph. Now, if you take a look at your notes, it does say that x equals h is a vertical asymptote. Remember, this was the only thing that was being logarithmed, okay? This guy was a k. He wasn't in parentheses, so he's not an h. So our h in this case is 0. So we have a vertical asymptote at x equals 0. So we might as well go ahead and plot him in. And then we can plot our points. So we have, okay, we have, don't plot them backwards, okay? Some people get confused since we made it backwards, they want to plot it backwards. But this would be over 1/3 up 0, over 3, 1, 2, 3, down 2, and then over 9, down 3. And this should be a curve to the right, okay? It's going to approach that asymptote to the left. Remember, this isn't like a starting point like what our square roots or cube roots are. That was just one of the points we created. So this continues to go on and on forever. It will approach that asymptote and go on and on forever. So if we think about domain, what is my x doing? My x is existing to the right of that vertical asymptote. So in this case, it's greater than, not equal to, because it can't touch that asymptote, greater than 0. Okay? My range, however, my range is going up to infinity and down to infinity. So my range is all real numbers. Okay? Let's try another one. All right. So for number 2, we have y equals log base 5 of x plus 2. Now remember, before we can do anything here, we have to get rid of that logarithm so that we can make an xy table that makes sense. What I mean by that is we can't figure log base 5. So there's nothing we can do right here to get us points. We can't even put it into our graphing calculator. So we need to get rid of this log base 5 so that we can make an xy table that makes sense to us. So here, this x plus 2 is locked in. So I can actually start by writing it as a power here. 5 to the y equals all of this piece. Okay, and then because I'm making a backwards xy table, I want to get that x by itself, so I'm going to subtract this 2. He doesn't go up in the exponent, okay, he's just being subtracted. Now I'm going to make an xy table. Now remember, use points that are going to be pretty to you, okay? And sometimes maybe you don't know. Maybe you have to play around with a couple points before you get some points that you think, yeah, I can graph that. Okay, that's completely up to you. But remember, we're putting them in for y and we're getting x. Okay, we're putting them in for y and getting x. So if I put 1 in for 1 in for y, that's going to be 5 to the first minus 2 is 3. 0 would be another one because anything to the 0 power is 1. So 5 to the 0 is 1 minus 2 is negative 2. And I probably don't want to put 2 in because that's going to be 25. So I'm going to use negative 1, which makes that's going to make that 1/5. It's going to flip it. And then I'll just use my calculator here. 1/5 minus 2 is negative 1.8. And that's doable. I can graph that. Okay. Now remember, I also have a vertical asymptote with logarithms because I can never have a negative x. So if we look back up here, we have an h, opposite of what it looks like, at negative 2. Okay, so here's negative 2. There's my dotted line. Make sure you don't plot backwards, okay? Use that xy table. So over 3, up 1. Oh, that was my bad. I can't use negative 2. That's going to be on my asymptote. Oh, that was my bad. 5 to the 0 is 1. 1 minus 2 is negative 1. Apology. Okay. So negative 1, 0. That makes more sense. and then negative 1.8, so almost to that negative 2, is negative 2. Okay, so now I'm curving to the right again and approaching that asymptote. And when I think about domain, x is everything to the right, of negative 2. It cannot be negative 2. So get rid of that equal to that I put in there. Okay, and then my range can be anything because it never stops. I know it looks like it shallows out here, but it will continue to go higher and higher and higher and higher as it moves right. So it is all real numbers as well. Okay, so that's graphing and finding inverses.